Okay, hi everyone, welcome back to this video series on data centers. Subnetting Class A addresses. Class A subnetting is not performed any different than Class B and C, but there are 24 bits to play with instead of 16 in a Class B address and 8 in a Class C address. Let's start by listing all the Class A marks. 255.0.0.0/8, 255.128.0.0/19, 255.192.0.0/10, 255.224.0.0/11, 255.240.0.0/12, 255.248.0.0/13, 255.252.0.0/14, 255.254.0.0/15, 255.255.0.0/16, 255.255.128.0/17, 255.255.192.0/18, 255.255.224.0/19, 255.255.240.0/20, 255.255.248.0/21, 255.255.252.0/22, 255.255.254.0/23, 255.255.255.0/24, 255.255.255.128/25, 255.255.255.192/26, 255.255.255.224/27, 255.255.255.240/28, 255.255.255.248/29, 255.255.255.252/30. That's it. You have at least 2 bits for the defining host, and I hope you can see the pattern by now. Remember, we're going to do this in the same way as Class B or Class C subnet. It's just that, again, we simply have more host bits and we just use the same subnet numbers we use with Class B and Class C, but we start using these numbers in the second octet. Subnetting practice examples. Class A address. When you look at an IP address and a subnet mask, you must be able to distinguish the bits used for subnets from the bits used for determining hosts. It shows you how to determine the difference between the subnet and the host bits and should help clear things up. Practice example 1A, 255.255.0.0/16. Class A addresses use a default mask of 255.0.0.0, which leaves 22 bits for subnetting, since you must leave 2 bits for host addressing. The 255.255.0.0 mask with a Class A address is using 8 subnet bits. Subnet bits 28 equals 256, host 216 minus 2 equals 65 534. Valid subnets. What is the interesting octet? 256 minus 222 equals 1.0.1.2.3, etc. all in the second octet. The subnets will be 10.0.0.0, 10.1.0.0, 10.2.0.0, 10.3.0.0, etc. up to 10.255.0.0. Broadcast address for each subnet. Valid hosts. The following table shows the first 2 and last 2 subnets. Valid host range and broadcast addresses from a private Class A 10.0.0.0 network. Subnet 10.0.0.0, 10.1.0.0, 10.254.0.0, 10.255.0.0, first host 10.0.0.1, 10.1.0.1, 10.254.0.1, 10.255.0.1, last host 10.0.255.254, 10.1.255.254, 10.254.255.254, 10.255.255.254, broadcast 10.255.255, 10.1.255.255, 10.254.255.255, 10.255.255.255. Practice example 2a 255.255.240.0/20. 255.255.240.0 gives us 12 bits of subnetting and leaves us 12 bits for host addressing. Subnets 212 equals 1496, host 212 minus 2 equals 1494. Valid subnets, what is your interesting octet? 256 minus 240 equals 16. The subnets in the second octet are a block size of 1 and the subnets in the third octet are 0, 16, 32, etc. Broadcast address for each subnet valid host. The following table shows some examples of the host ranges, the first 3 and the last subnets. Subnet 10.0.0.0, 10.0.16.0, 10.0.32.0, 10.255.240.0, first host 10.0.0.1, 10.0.16.1, 10.0.32.1, 10.255.240.1, last host 10.0.15.254, 10.0.31.254, 10.0.47.254, 10.255.255.254, broadcast 10.0.15.255, 10.0.31.255, 10.0.47.255, 10.255.255.255. Practice example 3a 255.255.255.192/26. Let's do one more example using the second, third and fourth octets for subnetting. Subnets 218 equals 262.144, host 26 minus 2 equals 62. Valid subnets in the second and third octet, the block size is 1 and in the fourth octet the block size is 64. Broadcast address for each host, valid host. The following table shows the first 4 subnets and their valid hosts and the broadcast address in the class A 255.255.255.192 mask. Subnet 10.0.0.0, 10.0.0.64, 10.0.0.128, 10.0.0.192, first host 10.0.0.0.1, 10.0.0.65, 10.0.0.129, 10.0.0.193, last host 10.0.0.62, 10.0.0.126, 10.0.0.190, 10.0.0.254, broadcast 10.0.0.63, 10.0.0.127, 10.0.0.191, 10.0.0.255. The following table shows the last 4 subnets and their valid host and broadcast addresses. Subnet 10.255.255.0, 10.255.255.64, 10.255.255.128, 10.255.255.192, first host 10.255.255.1, 10.255.255.65, 10.255.255.129, 10.255.255.193, Last host 10.255.255.62, 10.255.255.126, 10.255.255.190, 10.255.255.254, broadcast 10.255.255.63, 10.255.255.127, 10.255.255.191, 10.255.255.255. Subnetting in your head, Class A addresses. This sounds hard, but with Class C and Class B, the numbers are the same. We just start in the second octet, what makes it this easy. You only need to worry about the octet that has the largest block size, typically called the interesting octet, one that is something other than 0 or 255. For example, 255.255.240.0/20. With a Class A network, the second octet has a block size of 1, so any number listed in that octet is a subnet. The third octet is a 240 mask, which means we have a block size of 16 in the third octet. If your host ID is 10.20.80.30, what is your subnet, broadcast address and valid host range? The subnet is the second octet is 20 with a block size of 1, but the third octet is a block size of 16, so we'll just count them out: 0, 16, 32, 48, 64, 80, 96, voila. By the way, you can count by 16s by now, right? This makes our subnet 10.20.80.0 with a broadcast of 10.20.95.255, because the next subnet is 10.20.96.0. The valid host range is 10.20.80.1 through 10.20.95.254. Yes, no lie, you really can do this in your head if you just get your block sizes nailed. Okay, let's practice one more. Host IP 10.1.3.65/23. First, you can't answer the question if you don't know what a /23 is. It's 255.255.254.0. The interesting octet here is the third one, 256 minus 254 equals 2. Our subnets in the third octet are 0, 2, 4, 6, etc. The host in this question is in subnet 2.0 and the next subnet is 4.0, so that makes the broadcast address 3.255. Any address between 10.1.2.1 and 10.1.3.254 is considered a valid host. Summary: this chapter provided you with important understanding of IP subnetting. After reading this chapter, you should be able to subnet IP addresses in your head. This chapter is extremely essential to your Cisco certification process. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.